Okay, that only took a few seconds because it was the paper. I had it looking like this and I turned it over. Let's keep going here. And this video will probably be real short before I get into cis-trans to finish up. But this was the lindane, so I'm on number 4.34, page 177, which comes from this one. And if I redraw my lindane, which was way back on page, I don't know, 4.32 was from page, I don't know what it was from. 174. And, well, I'll just show it to you in the book here. It was this guy. It's an insecticide. Bugs don't like it. Probably doesn't bother plants or fungi, but bothers some bugs. Into the page, out of the page, out of the page, into the page, out of the page, out of the page. If I remember how I did this one, I called this one number 1, 2, 3, 4, 5, 6. So the third one would be into the page, it'd be down. So 1 is up, hydrogen's equatorial. 2 is up, hydrogen is axial. 3 is down, equatorial, hydrogen up. This one, chlorine's up, hydrogen's axial. This one's chlorine's up axial, hydrogen's equatorial, and then down for chlorine there. And so my interference here is 2 and 2 and 2 should be 0.6. I don't think I had that one right. There's 2, there's 2. I must have forgot this one down here is 2. The other way, flipping this chlorine down, so it's where equatorial now. Flipping that chlorine up, so it's axial here. This one down, so it's axial here. This one up, so it's axial here. This one down, so it's equatorial there. Okay, that's all the way around. So we have an up, which is 2, and an up, which is 2, and a down, which is 2. So that should be 6, 6, not 0.6. Now, I don't know, maybe I had it right the first time, but what was the question? Predict the difference in energy between them, if any. Doing it this way, I'm getting 6 and 6. I still come up with those points. 6 and 6, which is 0. I have that handy, though. The problem with that is the table doesn't give us enough information. If we ran this through on the computer, we would get it. And I don't have all my chlorines on here, but here's what I want to show you. It kind of depends on what else is going on with the molecule. If this, well, here's one thing. If you had a chlorine up here, okay, and you had some other chlorines up here, they have interactions with one another. So these numbers here are kind of skeletal overarching guides, but the numbers tweak after that, and that's why you need software to run this, because it gets highly complex. But without all of those nuances in the data, these two are more or less roughly a wash, unless I made a mistake there. Okay, so then to 4.35. Okay. We got compound A, compound B. And so what I'm going to do, it wants to talk about the twist boat. But before we do that, let's draw the chair conformations for both. So there's 2 drawings for this one and 2 drawings for this one. So I have on this one, I think I called this a 1 and a 2, and then this one it doesn't matter. Or a 1 and a 4. Okay, so yeah, there's my 1 position up, and on compound A, the 4 position is down. Okay, so there would be a hydrogen here, equatorial. There would be a hydrogen here, equatorial. And if this goes down on this side, then my hydrogen would be axial. And this tert-butyl would be equatorial, so the hydrogen here would be axial. And the way this is working, we've got, I don't know if I have numbers in there, but I think this is what, a 22.6 interference there and there? So that'd be, I don't know, 45.2? That would be hefty. This is going to really prefer this one. It's pretty heavy. Okay, which is what you predict, because it said it's predominantly in a chair conformation. Not only is it in a chair conformation, it is specifically in this chair conformation and not that one. And those were the numbers they give you, I think, earlier, where it was 9,999 out of 1,000, or out of 10,000. Okay, compound B, I have 2 of them up out of the page. Okay, so when I draw that one in the 1 and 4 position, I will have one up and the other one up, because this is hydrogen equatorial, this is hydrogen axial. They're both up out of the page. And if I flip it over and put this one down here and the other one comes up, it's just the same as rotating the molecule around. I get the same thing. In both cases, they're 22.6, I think it is. So and that's pretty hefty. That's a really hefty interference. It's bigger than, 6 or 8. So there's got to be a better option. Well, the better option is to get these 2 guys away from each other. And the way to do that is to take you can't get this just by flipping these around. You actually have to have them rotate like so. I don't have that one ready to go, but yeah, you want the twist boat, and not the twist boat where they do this. This would be impossible to do. But the twist boat where they're both in equatorial and you have a hydrogen up here on the axial positions. So this is definitely what it's going to do, because it gets those isobutyl or tert-butyl groups away from each other. Okay? So I'll do the next part, cis-trans stereoisomerism, and the other questions on the next video here, if I can fit it in one.